Hello everyone. Today we are going to discuss GPU. GPU is a buzzword that you keep hearing in news quite often these days. The microprocessors in general, they are going to be the central unit, the central piece, the hinge on which the techno geopolitics of 21st century is hinging from. In 20th century geopolitics, it was about resources, petroleum. In the 21st century, the keyword is techno geopolitics. It is hinged on technology. And the technology control regime that earlier they had in space and the nuclear science and defense now is coming to AI and the related ecosystem. And in that ecosystem, one crucial unit is GPU. So, what's that? You are very familiar with CPU. You have heard of it since your early childhood, class 6 perhaps, when computer science as a subject was introduced to you. CPU, Central Processing Unit, the brain of the computer that does all the algorithmic work, and the complex task is done by CPU. GPU is the graphics processing unit, and the reason why it is called as graphics processing unit is because initially it was used for that very purpose, graphics, display. In 1999, NVIDIA introduced its GPU that it called world's first GPU, GeForce 256. This is not important for the exam, but I'm trying to tell you that it was used for display in video games to improve the visual appearance of the video game. It was used. Now, to improve the visual appearance, the graphics as we call it, there are thousands of pixels on the screen, and you have to change the color very often as the movement happens and as the screen changes, so to say. So in every pixel, the color and intensity has to change very fast for better visual appearance. So it's a simple task. It's a repetitive task, but it has to be done at very high speed. So GPUs are exactly that. Exactly. And if you pick up this much, you have picked up enough on GPU. GPUs perform simpler tasks. They do not perform complex tasks. Complex thing is still done by CPU. Simpler and repetitive tasks, but are done at higher frequency. That is GPU. So GPU increases the speed. It increases the frequency with which few sets of activities are done. That is GPU. Not only related with graphics. Now the expansion into various territories and training LLM and other things. But since initially it was used for graphics, so the name is clinging on to it still today. So we still call it GPU, Graphics Processing Unit, but it is not limited to graphics. For your prelims exam, this term is important, I'm telling you, GPU, and you have to be very clear about it. The difference between CPU and GPU, as they call it core. There are few cores and they're powerful cores, the functional unit in CPU, but there are thousands of smaller cores. These smaller cores, they perform simpler tasks, but there are thousands of them. So they do it faster. They're not superior in their design. They're not. But they're specialized in their job. So they will be able to do their job faster. The speed is of essence in GPU, not the complicated design. For complex and sequential tasks, it is still CPU. And the CPUs and GPUs are microprocessors which are on the same motherboard, the motherboard which is responsible for development of the brain, the central part of the CPU. It's still there. It's not a different layer. GPUs are not a different layer over and above CPU or below CPU. It's there. In the general design of CPU, these chips are absorbed on the same motherboard, but performing some specific task. They are complex and things that happen sequentially, but they are simpler and things that happens repetitively. Simple and repetitive tasks, they are performed by GPUs. So GPUs are designed for some specific things. As I put here, you can have an analogy that CPU is like a brilliant professor who will have answers to most of the questions that a common man has to ask on, from astronomy to mathematics to physics to chemistry and biochemistry and environmental science. He will explain the phenomena of the weather, and he'll explain the phenomena of gravity, and he'll talk about black hole and dark energy. He's a brilliant professor. He does everything. But you can't have him all the time. And if he has to do everything and answer all your questions, will take too much of time. Suppose, imagine this brilliant professor is given the task of evaluation of school class 8, 9, 10th, the answer sheets. In the evaluation of the answer sheets, the same questions are evaluated multiple times. The professor evaluates, no doubt he will evaluate with better precision and his judgment will be better on each answer. So his marking will be more accurate, no doubt about that. But will you give to the professor the job of evaluation of every paper of the entire class, 50 students in the class, and the same question paper for all, this repetitive task? No. But a person who is quite familiar with less can also do it, but rather do it faster. So if you have 10 teachers from the school evaluating the question paper of the same class, a kind of repetitive job, and the 50 question paper divided into 10 of them, 5 each, the job will be done faster than what this brilliant professor will do, because they are more in number and they're specialized in a particular task. That's it. They will not be able to perform if you ask them to do something else. They are specialized. They do simpler things. They do repetitive things. They are more in number, so they do it faster. That is it. So that is the idea of GPU. So the operating system that's run by the CPU. The general computing also done by the CPU. But graphics rendering, AI training, training of LLM, crypto mining, scientific simulations, finding the structure of the protein, very specific, niche, specialized, repetitive. That kind of job is done by GPU. So on the face of it, that's that. The design, the complexity, I'll not dabble into it. That's not required for our exam. And, that becomes very technical, but our job is to avoid the technicality and understand things in a general way, in a more application-oriented manner. So I'm going to just tell you whatever I've told you already. In technical terms, it's called as parallelism. As the name suggests, that you do parallel job. As if you have idea of quantum computing, in the quantum computers are faster than classical computers. And the reason why quantum computers are faster, because they also do a parallel task. The same task is broken into pieces and all the steps are run parallelly. That's the exact reason why 4G was much faster than 3G, because of parallel communication. The message that we're trying to upload are broken into pieces, and with various switches, the gates, whether in the Wi-Fi or in the telecommunication tower, they go parallelly. Imagine a toll plaza and there are multiple gates. There are multiple gates and there's one road leading to the toll plaza, and then they spread. And anybody can go anywhere, and you distribute the traffic, it gets faster that way. Exactly. That's the idea. So you break it into pieces and run the operations parallelly. That is called as parallelism. In the architecture, it's called as single instruction, multiple data. On this architecture, GPU mostly works. The instruction is simple, so the job is simple. It's a single instruction. It's a simpler job, not a complex job, single instruction. But even that instruction is done in parallel steps, multiple data. So one job broken into multiple pieces, and multiple pieces done simultaneously. If something specializes in that thing, of course, will be faster. Okay. So does GPU does complex set of tasks? Can it run the operating system? No. Is it complex, very complex in its design inherently? No, it's not very complex in its design. Is it faster? Yes. Is it smaller than CPU? No, they're not smaller. They're more in number. Rather, their size will be bigger than CPU. They're substantially larger in size. It's not that they have developed miraculously very small chips and that special chip is called as GPU. GPUs are not smaller in size. They're not smarter per se. They're algorithmic and they're repetitive and they are working in a niche area and they work parallelly. They are more in numbers. That's why they are faster. That's it. So I hope you are getting the knack of it. Now, exact functioning, if you see, there's a explain article in the Hindu today, and they kind of explain how the GPU works. And I've read the article. That's well explained. If you can understand, that's well explained. But that's very technical, and that is far away from the pattern and the demand of the UPSC exam. So if you have happened to read that article of the Hindu, the explained section, you may have got it, you may not have got it. If you didn't get it, it's a good news. You are not required to get that. That's actually a very technical article. So I'm telling you as much as is required and nothing more. I guarantee to you, nothing more than this. What else I have to tell you will be required for your exam. The GPUs, they have suddenly become very important because the programmers and the engineers, they have suddenly realized that the thing for which the GPUs were used to change the graphics, change the pixel colors, the intensity rapidly, the exact same algorithm is used for LLM training as well, for machine learning. For scientific simulations, the same activity of GPU is required. For crypto mining, the process of, if you have done cryptocurrency, you understand that they are on blockchain, and blockchain has an inherent design that the data cannot be changed very fast. Whatever the changes have happened, that has to be understood by the system, and if the system gives go ahead, majority of the people vote on it, there is consensus for a change, then the change will be acceptable. So you can't be changing the system at rapid pace and you change everything. Blockchain inherently has a design of a speed breaker that slows down the speed of change that you can do on the blockchain. So how is it done? Blockchain, the system gives you a mathematical problem to solve. And meaning your processor, the gadget that you're using, will be engaged for 10 to 15 minutes in solving that. You don't solve it, your system will solve it, but the processor will be engaged too much, will require at least 10 to 15 minutes to solve it. And then an answer will be generated by your system. You give it to the blockchain of the Bitcoin cryptocurrency, and the answer accepted. Then this is called as proof of work, meaning just to hold you back for 10-15 minutes, a job has been given. And you do the job, your equipment is engaged in that, and then so that you can come only after 10 to 15 minutes. That's the idea. So nobody has a capacity to rapidly change it. Everybody will be given task. Once you do the task, create the right answer of the mathematical problem, then you come. So you see, it's a repetitive thing. You want to make 10 changes, do one change, show the proof of work, then the second change is permissible, then show the proof of work, third change is permissible. It's a repetitive task for crypto mining, also for defense, for satellite image analysis, for signal intelligence. They all are going to use GPUs for many of the data centers. In the data centers where the calculations are in a similar way, a lot of them are done in a same pattern, wherever things are algorithmic and repetitive, then the chip can be designed to perform that task. I'll give you a little bit of idea so that you have a little bit of feel as to exactly how that is done. Okay, this is just for the feeling purpose, not even for understanding. See, generally, the data are stored in a matrix form. So maybe you have y1 and y2 and y3. These are the columns, and x1 and x2 and x3 or x4. These are the rows. And you have some data here and some data here and some data here. And if you have stored some data and you want that data to be retrieved, then you give the message as x1 or y2 or x1 or y3. x1, y3, this data will be retrieved. x1, y2, this data will be retrieved. So depending on that, so the data are retrieved according to how they are stored. Now this is a very general task, and anything can be retrieved from anywhere. And the tasks are generally performed row-wise and column-wise. They are not designed to perform a task like this or perform a task like this. That goes in a row or in a column. That doesn't go diagonally or the performance of task in any specific way. But you can have just a coding to design the microprocessor to work in a particular algorithmic way so that this row and this column gets multiplied very fast. It is programmed to do that. So it is programmed to do a particular kind of calculations, a particular kind of functions. That is the idea of GPU. So GPU per se is not more brainy, is not inept to do more complex things, but is designed to do simpler things, and it has a specific design, and there are too many of them. So they do simple, repetitive tasks at a higher speed. That is the idea of GPU. And there are so many things happening around now that the demand of GPU is enhancing. GPU also requires some amount of good design. It's not that it's very easy to design GPU. Designing GPU is also difficult, and fabrication is of course difficult. So technical thing I'm not going to tell you. So whatever I've told you is enough for us. We do not need to get into the technicality of GPU as to how it is done. But you need to know that NVIDIA has near dominance in the GPU ecosystem globally. 90% of the market share of all AI GPUs are within NVIDIA. NVIDIA based in USA, and USA virtually controls the supply chain of GPU. NVIDIA is into design, I hope you know that, and I have given you here the ecosystem. 90% of the chip design is with NVIDIA, and in the rest 10% we have AMD and Intel. So almost 100% of the design ecosystem is dominated by these, almost 100% by these three companies. But TSMC, Taiwan Semiconductor Manufacturing Company, TSMC, this is a crucial piece in the ecosystem, and this is a fabricator, meaning the design of NVIDIA is manufactured, fabricated in the factory in Taiwan. Taiwan manufactures the design of NVIDIA. NVIDIA is largely into design, and TSMC is largely into manufacturing. And the collaboration of the two is quintessential. If that breaks, then the system will collapse. So Taiwan has special favors from USA. It has to have. If Taiwan is stopped to do that, maybe China someday try to be aggressive and stops, then the economy of US will start to crumble. The dominance in AI will start to crumble. And that will precipitate a war. US will leave no stone unturned to protect the Taiwan economy and protect this relation with Taiwan. So this is crucial. China has been barred, and I tell you the law that the US had enacted. China, Russia, and North Korea, they have been barred from holding the supply from the US-based companies of the, as we call it, AI chip or GPU. But Huawei has stepped up, and indigenously they are developing off their own. Right now the share is less, but after the Donald Trump administration had aggressive posture against China, Huawei has started to develop their own microprocessors and AI chips, as we may say it, GPUs. But that is at the initial stage. Maybe in the future, Huawei will also pick up. So the design of GPUs, that's dominated by NVIDIA, AMD, and Intel. Fabrication by TSMC. This is one of the major global company of the company of Taiwan into manufacturing. Then there's company of the Netherlands, ASML. ASML has the monopoly of developing the technology, extreme ultraviolet lithography machines. That does the manufacturing of very advanced chips, very, very small in size. And again, US has very good relation with this Dutch company, and the policy of this company is regulated by US, and they're not allowed, and they maybe willingly they're not giving, or the US policy is not allowing them to give this technology to anybody else. So one in Taiwan and one in Netherlands, ASML in Netherlands and TSMC in Taiwan. These two are acting like vassals of US, and they are very, very crucial in the supply chain management of the semiconductor industry. If you are familiar with this, we have discussed in the discussion on the semiconductor earlier, I believe. It is called as assembly, testing, marking, and packaging. Either we say it ATMP, assembly, testing, marking, and packaging, or OSAT, outsourced assembly and testing. Assembly and testing. So OSAT facility or ATMP facility. And this is a model where these companies, they make the chips and the assembly of that on motherboard, putting things together, the wiring and the low techy thing. That is sent to many countries, and India also is coming up with many assembly units. Like for the screens, the LED screens of the electronics, they're made somewhere else, and we have assembly units in India. Because we are a huge market, so there are a lot of assembly units for electronic industry. Similarly, we are also coming up with assembly units for the semiconductor industry, but there is zero manufacturing currently. There's a planned manufacturing lab, fabrication lab in Dhulera in Gujarat, but we are few years away from having the manufacturing in India. The end use in data centers and the cloud providers and the AI labs, the research institutions for defense, for satellite imagery and for remote sensing satellite services, end use are many. There are many end users, and the demand of GPUs is only going to increase. For your prelims and also for your mains, you have to know that in January 2025, towards the fag end of the Biden administration, they enacted this law, framework for artificial intelligence diffusion. And they categorize the world into 3 categories. In tier 1, they have their close allies like UK, Japan, Germany, France, South Korea, Australia, the 18 countries there, and they will have unrestricted access to advanced GPUs. You have to know, and you have to know this very, very well, India is in the tier 2 category, and 120 countries like UAE and India and Israel and Singapore, they are in tier 2 category, and they are capped access. There are national quotas. Currently, they have given 50,000 GPUs as national quota. They will not provide ordinarily, unless we have a separate bilateral agreement. Ordinarily, they will not provide more than 50,000 GPUs to India. And then there are tier 3. They're effectively banned from receiving advanced AI chips. And here you have China, Russia, North Korea, Iran, Libya, etc. To remember this very, very well. China, they have put in tier 3 countries. Okay. So India is placed in tier 2, and approximately 50,000 GPUs, H100 equipped GPUs. This is the model number. We don't have to bother about this. So there's a capping. There is a capping. The GPUs, they are going to be the fulcrum of techno-geopolitical competition. And having GPUs, like in the previous era, having missile technology or space-based technology, having our own GSLVs and having our own we still did not have fully, but we started to now have gradually the nuclear reactors, doing at least the nuclear testing, having nuclear capable missiles, having our own ICBMs, having our own supersonic missiles, having our own supercomputers. It is like that. It is, trust me, it is that important to have our own GPUs. Otherwise, there'll be question on digital sovereignty, strategic autonomy, technological colonization, and the balance between national security and free trade. If we don't have our own GPUs, if we don't have our own data centers, if we don't have our own LLM, if we don't have our own operating system, if we don't have our own AI chips, GPUs and TPUs and NPUs, there's a serious question on our sovereignty in the modern digital era. There are problems of import dependency. Currently, India has 0 domestic GPU manufacturing, and our first manufacturing lab is going to come up in few years. US export control risk, and despite we have an interim trade agreement, but as they have barred China, the diabolical nature of the current president, we do not know when they can cut it off for India as well. There's always a risk of import embargo. The energy demand of GPU is very high. As I've told you, they do repetitive tasks at rapid pace. They are fast and there are too many. So obviously the energy requirement will be very high. GPUs, we are now looking for the idea of green data centers. Data centers where GPUs would be there, it will be fast, no doubt, but everything has a cost. And the speed will come at a cost of very high energy demand. So as we are looking for manufacturing of GPU or more and more imports of GPUs, at least for the time being, and in the future manufacturing, we'll have to see simultaneously how do we solve this problem of making the data centers green, and how do we have this meeting of the surge of energy demand. Talent retention. I've given you this data earlier as well, that 20% of the global design engineers, they're Indians. But the catch is they're not working, many of them, in India. They're working in India as well because the R&D centers of global companies are in India as well. Like Qualcomm and Intel and Samsung, they have their centers. But bulk of them are working outside of India. And even in India, they're working for foreign companies. So If the companies go, they'll take the talent also with them. We have to do something to develop the indigenous ecosystem, startups, and absorb the talents there. Long timeline for indigenous GPU. Our GPU, if we try very hard, cannot come before 29 or 30. And also by this time, maybe 2030 or 2032, our SMRs, small modular reactors, will be ready. The timeline will merge, because when they are ready and we are having their absorption more and more, the energy supply also has to be done. So both has to happen simultaneously, but still, this will give edge to other countries and also China to have their roots more deeper in the techno geopolitics. We have to catch up. If not sliding it up, then at least we should not miss this timeline. There's always a threat of digital divide. More of these infrastructure will be urban centric, and the rural India may remain aloof of these development. So government of India is trying very hard. You may be hearing of Bhashini, the LLM model that translates the speeches or the text into multiple local languages. And during the AI summit, for the first time, it was used to that scale that the speech of the Prime Minister was being translated into 7 regional languages simultaneously. So government is trying this hard, very hard, I think, that the ecosystem does not create more and more digital divide. So that is a good thing that is progressing, but we need to do more on that. So what should be our roadmap? Our roadmap has been announced in the budget. The fundamental thing, a fundamental shift has happened from India Semiconductor Mission 1 to India Semiconductor Mission 2. Here we have shifted from giving incentives, production-linked incentives and design-linked incentive, to create a manufacturing ecosystem. That mindset, that approach has changed, and it had to change. Without that, we cannot compete with these giants that are around. We have to have a more diversified supply chains. We can build partnership beyond US with Taiwan and TSMC. We have PSMC, the Tata Electricals and PSMC. They're having collaboration in Dholar and Gujarat fabrication. We have not managed to develop a joint venture or any kind of collaboration with TSMC yet. We should try for that. Some diplomatic maneuvering is required with South Korea, with Europe, ASML. Maybe if we try to have some collaboration with ASML, which will be more difficult because that is the single company in the entire world that brings EUV grade microprocessors. But we require to do that. Like in the space, we have had collaborations with Russia and with France, also with NASA. That collaboration is required. That will be crucial to develop our own ecosystem. We need to democratize the AI compute. AI compute is a term related to the computational capability of AI. We need to continue on that. And like I have explained you in the last video as well, the AI ecosystem in India is democratic. Government is funding, but the fund is given not to PSUs, but to the private sectors, and everything is kept IPR free. So this is something happening already, and this must be kept this way. Green AI infrastructure, the huge demand of energy by the GPUs, and the upcoming data centers incorporating GPUs and other things. We'll have to check on this as to how we meet this demand. Scaling up of renewables, of course, but more and more nuclear energy in the most safe way, the small reactors, that would be required. The talent development. We have Anusandhan National Research Foundation, but the collaborations of our institutions, without collaborating with institutions, nothing has happened in India. Nothing. In anything that we have developed, even in IT or space or defense, it's not that a monolithic DRDO has done, a monolithic ISRO has done. IASC and ISRO and other institutions and IITs, they have collaborated, and an ecosystem existed that acted as a launch pad in these sectors, whether in energy as well, renewables. This is not happening. You see, there is a lapse that government is funding and startups are taking up the advantage of the fund and they're doing their research. Where are the institutions? BharatGen, for example, has been worked out by the IIT consortium, which is good. But there has to be an ecosystem, and the grassroots institutions must take lead in the research. Otherwise, government funding and few startups leading will not cut the ice. It won't happen. Will not become giant that way. So the ecosystem that needs to be developed, and these are our grassroots research institutions. They must get into collaboration with NVIDIA and others. In the last class, maybe, or maybe in the future videos, I'll discuss about all that has happened in the recent AI summit. In the recent AI summit, Prime Minister has given his vision of Manav framework for AI. And that needs to be worked upon. And that ecosystem in the humane way has to be developed in a democratized world order. Okay, that is it for today. Now we'll do some questions. I'll read the statement. You'll tell me true or false. You must get the answer before I give you the answer. A GPU is primarily designed for serial processing of complex tasks, which is false because parallel processing of simple tasks. Remember this. GPU is not in every sense superior to CPU. This is the job of CPU, not GPU. Serial processing of complex tasks. GPU goes with parallel processing of simple tasks. NVIDIA holds approximately 90% of global AI GPU market share. This is correct. NVIDIA has captured it, and the European Union had an investigating body to see that is NVIDIA practicing any illegal means to do that. It is not technically monopoly of NVIDIA because they're not, technical definition of monopoly includes measures that you do not allow others to compete with you by some illegal means. But NVIDIA is not doing that. But NVIDIA sells a software that system runs on. That software is compatible with the GPUs of NVIDIA. If you change the GPU, like Intel also provides GPU, but if you go to Intel's GPU, then you have to change the software as well. But the software, the companies are very familiar of that of NVIDIA. So clubbing the GPUs with the larger software that the system runs on, that's how they're taking the advantage. So NVIDIA has the dominance. That is true. And 100% of India's GPU is from NVIDIA. Under the US AI diffusion framework, India is classified as under tier 1, which is wrong. India is under tier 2. Their Western buddies, they are in tier 1. So this is false. The India AI mission has a budgetary allocation of over 10,000 crore. Yeah, that's little over 10,000 crore. 10,372 crore maybe. That is right. That is right. Not that this number has huge significance, but I had to make a comparison that for the Semiconductor India mission, India Semiconductor Mission 1.0, the budgetary allocation was 76,000 crore because that is fabrication. And fabrication is very costly. Setting up the factory for that is very costly. 76,000 crore, there's 10,000 crore here, and this is also a huge number. But nevertheless, this is true. TSMC, the Taiwan Semiconductor Manufacturing Company, is the world's largest manufacturer of advanced semiconductor chips used in GPU. This is true. NVIDIA is the designer. This designs and TSMC this manufactures. The US and Taiwan, they have to be together. If this bonding breaks, then their hegemony breaks. All right. Would you like to do some MCQs as well? A GPU is designed to perform a few complex tasks very quickly in a sequential manner. We have done this there as well. GPU is not designed for complex calculations. They are designed for not few, for many, millions of simple tasks. So this goes. The strength of GPU lies in its ability to perform thousands. This is right. Term GPU was coined by Intel in 1999. This is also right. So the answer should be C. With reference to the difference between CPU and GPU, a CPU has thousands of smaller cores. A CPU has less number of larger cores. The GPUs are single instruction, multiple data. That's right, simple. It does simple task. Even the single instruction has broken into multiple and parallelly run. Single instruction, multiple data. That is the architecture. That's right. CPUs are better suited for running operating system and handling complex decision-making tasks. Yes, CPUs will not be replaced. CPUs will always be there. And GPUs are going to be there for specialized tasks. With the following application primarily rely on the parallel processing capability of GPU. Parallelism is there in GPU, parallel processing capabilities. LLM model training, weather forecasting, word processing and spreadsheet operations, cryptocurrency mining. Well, spreadsheet operations that may not be repetitive. The data that you're using every day will change and the calculations will change. Word processing is not repetitive. To some extent, spreadsheet operation could be, but word processing is not. So this has to be removed. I think the answer should be B. This is an important question here. A single high-end GPU can consume approximately 12 kilowatt hour. UPSC does not give number as such, but this number is right. GPU data centers typically have negligible energy requirement. Come on. GPUs will increase the energy requirement. Right? Then let's do this last question. NVIDIA, GPU design, TSMC, fabrication, ASML, sole manufacturer of EUV lithography machine. And all of them are right. All of them are important for you to know. All right. See you tomorrow with a new topic.